Hello everyone, thank you for joining me today. My name is Hugo Santiago and I will be presenting my final project. My final project is titled Cloud Native Architecture and AI Governance in Medicaid Adjudication. The work focuses primarily on cloud technology and responsible AI practices and how they can support efficient, transparent, and compliant prior authorization and eligibility processes. With these new federal rules reshaping how automation must function in healthcare, right now is a critical moment for Medicaid programs to modernize their entire processes and systems responsibly. Medicaid adjudication is under immense pressure. States now face growing workloads, outdated systems, rising expectations for turnaround times, and AI offers a powerful opportunity to reduce administrative burden and to essentially speed up decision making. Both AI and the current systems need to work in tandem, but AI inherently brings an array of risks like inappropriate denials, algorithmic bias, and even privacy concerns. And this is especially important because decisions directly impact access to care for the most vulnerable subsets of our populations. As a response, recent regulations, including CMS 0057F and ONC HTI-1 rule, are now requiring explainability, transparency, and FHIR-based APIs and monitoring of automated decisions. So this presentation will focus on how cloud-native designs, strong security, and modern governance frameworks allow Medicaid agencies to deploy these AI systems in an efficient but also, most importantly, a compliant way. At its core, cloud computing has become the most essential component of Medicaid systems. Cloud environments are elastic, they're pooled, they're automated, they're service oriented, and the qualities match perfectly for the needs of AI adjudication. So cloud platforms allow real-time data exchange and rapid scaling during peak workloads. However, along with these benefits, they also introduce sharp responsibility boundaries and multi-tenant risks that Medicaid programs must govern carefully. In short, cloud isn't just an infrastructure choice, it's what enables AI to operate reliably, securely, and at scale. Event-driven architecture is one of the most effective cloud patterns in AI adjudication. Instead of waiting for manual triggers or batch processing, every event, like prior authorization submissions, immediately initiates an automated workflow. This means AI can evaluate requests in real time, essentially improving turnaround times and reducing provider burden. Just as important are event logs that create a complete audit trail that supports transparency, appeals, and compliance with CMS reporting requirements. API first design is an architecture that complements event-driven processing by ensuring that every system interaction is standardized and interoperable. CMS 0057F requires payers to implement FHIR APIs for prior authorization, patient access, provider access, and payer-to-payer exchange. By structuring adjudication AI around these APIs, Medicaid systems gain several benefits, including clear integration with EHRs, machine-readable decision explanations, consistent data exchange, simplified monitoring, and API-first designs is essentially what allows cloud-native AI to plug into modern Medicaid ecosystems and allow them to function effectively and efficiently. In terms of cloud security foundations, because AI relies on PHI, security is not optional. It's a central compliance requirement. Guidelines like HIPAA require strict controls over access, storage, and transmission of health data. In cloud environments, this means implementation requires strong IAM with least privilege access, multi-factor authentication, encryption at rest and in transit, comprehensive audit logs. The cloud shared responsibility model is also something important to highlight because cloud providers secure the infrastructure, but Medicaid agencies are fully responsible for the configuration, the access, and the proper handling of PHI. This distinction is critical for compliance and allowing organizations to remain compliant with these evolving regulations. Monitoring, logging, and model security. And at its essence, security doesn't end once a system is configured. It's a continuously monitoring process, and that's essential. Cloud-native telemetry detects unusual activity, API abuse, or unauthorized access. For AI specifically, it monitors several different aspects. It can detect model drifts, it can identify bias or performance degradation, it can track unexpected changes in outputs. These capabilities support compliance with HIPAA, with CMS oversight, and even with ONC HTI-1 requirements for algorithm transparency. Logging and auditability also ensure that agencies can explain how decisions were reached, which is a key requirement for prior authorization. AI governance ties directly into everything. It ties it all together. The NIST AI Risk Management Framework specifically provides a structure. It's governed by a section called Govern, Map, Measure, and Manage. All of these areas help organizations identify risks, apply controls throughout the entire AI lifecycle. ONC's HTI-1 rule requires developers of predictable algorithms to disclose source attributes like training data, performance, limitations, fairness testings as well. This is needed to avoid black box tools. Civil rights obligations under Section 1557 prohibit discrimination or any discriminatory impact, and HHS OCR now explicitly applies to these protections for AI services. In short, governance ensures Medicaid AI is accountable, explainable, and equitable. Ethical AI is especially important in public benefits. Best practices include human-in-loop review for adverse decisions, clear machine-readable denial reason codes, regular bias testing and fairness reviews, transparency and beneficiaries about how and when AI is used. These principles aim to protect vulnerable populations, but also align AI use with public sector values. AI also introduces new cloud costs and considerations. Event-driven and serverless architectures reduce idle costs while auto-scaling ensures performance during peak volumes. However, AI inference workloads can become expensive without FinOps governance. Agencies, therefore, must monitor compute costs for inference, storage costs for models and logs, API transaction costs. Service quality is equally as important. SLA expectations include availability, latency, and response times, especially in real-time adjudications. Cloud architecture directly impacts whether agencies can meet CMS timeline requirements as well, and that's perhaps the most important element. As we look across architecture, security, governance, and compliance, a clear theme seems to emerge. Cloud-native design enables AI innovation, but only when security and governance are built in from the start. Federal regulations are pushing agencies towards transparency, interoperability, and fairness. These aren't optional, they're essential for trustworthy AI and Medicaid. Ultimately, AI should support and not replace human judgment. As we move on to recommendations, there are some key areas for Medicaid agencies when they are deploying AI. They include adopting NIST AI RMF as a foundation for lifecycle governance. They also require ONC-style model documentation from all AI vendors. They need to implement automated monitoring and bias dashboards. Humans need to remain as reviewers for all denials, especially in complex cases, and there needs to be an establishment of FinOps programs to govern cloud AI costs. These steps will help ensure that AI remains transparent, compliant, and aligned with public sector values. So to conclude, AI will play a major role in the future of Medicaid adjudication. Cloud-native architectures give agencies the tools they need to build scalable and interoperable systems. Security and governance frameworks ensure AI is deployed responsibly, and ultimately, ethical, compliant AI can reduce burden, improve turnaround times, and strengthen trust in public health programs. Thank you very much for your time.